and data sciences. We also do consulting for the same. The format of the talk, so that you have a sense of how things are going to move forward, is that we will have the tech talk for till about 11 o'clock. From 11 to 11:30, it is going to be a Q&A session, so that all your questions can be addressed. From 11:30 to 11:45, we will have a short break. From 11:45 to 12:30, we will again continue with the talk, and 12:30 to 1 again will be the Q&A. The first half of the session is primarily going to be on big data itself, and the second half will be more on Hadoop. So if you have any queries, for those of you who are sitting in the rooms, please, and who have individually logged in, please just raise your hand. You'll have an option to raise hand. Please just do that, and our presenter will unmute you, and you can ask your query. Our presenter for the day today is Sandeep Giri. I will let him introduce himself.
Good morning, everyone. This is Sandeep Giri here. Let me just mute everyone. I'm getting a lot of echo. So can you hear me? I see that there are a lot of people who have logged in from their desktop, and then a lot of people are in the conference room, right? So those who are in conference room, please raise your hand, and then I'll unmute you, because that's the only way to ask question. Those who have their laptop, please ask the question by typing into the chat, uh, the chat box. So you can ask your question by typing. And those who are in the conference room, they cannot type, so I'll have to mute that particular attendee so that they can ask the question by voice. So the format, as Anjana told, the format is that 1 hour talk and half an hour question. Then 1 hour talk, half an hour question. It's just that there'll be a 15 minutes break. Okay, so let's start. So we have a great set of attendees. We have got 24 attendees in this session, and there are lots of people who are logged in from various conference rooms. So I'm assuming that the attendees would be above 100. That's my guess. So as Anjana gave an introduction about KnowBigData. Basically, we are into big data and data sciences, consulting and training. So this particular session is first of our sessions on Hadoop and big data. First, we will describe what is big data, and then we will talk about in detail, like how does the problems of big data solved by this particular suite of components called Hadoop. All right. So now let me start. And let me introduce myself. I did my BTech from Roorkee somehow in 2002. And after that, I worked at DE Shaw. There, I was working on big data systems when the term was not even coined. So we had a cluster of 10,000 nodes, and we were exploiting that cluster to do a lot of data churning, lot of humongous data churning. Okay, we used to call it humongous data or mammoth data. We never called it big data. Right now, after that, I started a company called Tbits Global. That was a document management company, and one of the biggest customers of our document management system was L&T Power, Larsen and Toubro, your own subsidiary. And that's where I interacted with lots of people from L&T Infotech also. And after that, I joined InMobi and built couple of uh, product which needed a lot of data churning. One of them was Recommender. We churned around 200 terabyte of data to build recommendations. Okay, we were giving users recommendation based on their past behavior. And after that, I joined Amazon. I mean, there also I was working on big data related products, such as product detail page, where we show you may also like it, because Amazon is one of the pioneers of big data, and that's where I got reintroduced to lot of other kind of data processing systems. I built a couple of high throughput systems there in 1.5 years, and then in 2014 I started Know Big Data, and so that's pretty much about me. Today we are going to talk about big data and Hadoop architecture. All right, and in today's class, what and why of big data, why now, example customers, and then what is Hadoop, then what are the various components of Hadoop, and then we'll go into the architectural details. All right. So before we proceed to get into the details about big data, the first primary question is what exactly is big data. So those who can type, they can type their answer quickly into the chat box. Okay. And okay, so this definition itself is a, the everybody has their own kind of definition for big data. So I will just make it very, very clear when we talk about big data. First, big data means huge data. It does not mean big data solutions, big data problems, or big data insights, big data analytics. No, big data means just data which is huge. Okay, and how huge, that we will discuss now. So the biggest question is, how huge is your big data when we start? How huge is the data when we start calling it big data? Okay. So in very, very simple definition, the the data so big that you can't process with your usual tools. Usual tools as in your usual relational databases, your usual file systems, and your usual uh, uh, computers. When you can't process it using your existing tools, then we call it big data. Okay. And the most important characteristic of big data is that to process big data, you need multiple computers. The moment you hit a roadblock, that even if you vertically scale as in you increase processor, increase RAM, increase hard disk, or you buy a supercomputer, still, when you are not able to process or store data, that moment we call it that you are doing big data storage or big data processing. Okay. And the other characteristic of big data is that it can be structured, unstructured. Okay. So this is the IBM's way of defining big data. There are four V's which define big data. One is it has got a huge volume. V, and then second is it has got a huge velocity. When we talk about volume, so as you can see that like for example, Facebook itself generates around 500 terabytes of data per day. And I'm sure none of us have handled a database in MS SQL or Oracle of that bigger size. Okay. So that is the kind of volume when we talk about big data. As I was talking about the recommendation system, which I designed at InMobi, it was 200 terabyte of data, which we were churning at that point of time. So that 200 terabyte of data becomes a nightmare in when you use the existing tools, such as any relational database, Oracle or a Microsoft SQL. It becomes a nightmare when you try to handle 200 terabyte using any of the systems. Okay. So when you see such kind of a volume, then you call big data. Then you call it a big data. And then second characteristic of big data is velocity. velocity as in the data in motion. There are circumstances when you see that the data is not so huge and still your existing systems cannot handle it. Okay, that is the case where the data velocity is too high. A classic example of velocity is when you hit a website from, say, during when take a case of say Amazon's website. Lot of customers come in. Even if they don't generate too much of data, they just visit the website. The load is too high. The data velocity is too high to be handled by a single system or any supercomputers for that matter. That's where you require a distributed architecture or multiple computers to handle that kind of load. So, and the other examples of velocity is any, say for example, YouTube. It's a single video being distributed all across the world, and to serve that video, you require a specialized system to to distribute the video. Even though it's the same 1 GB video, but the velocity is too high. There's so much of movement of data that it is characterized as big data because you need multiple computers to handle that kind of scenario. Now, third one is variety. Earlier in 1980s or 1990s, we called any data, we only respected a data which was relational in the form. Okay. And the moment we strike a non-relational data, we used to say that it's none of our problem. These are just files. Okay. But and if you see images and other kind of complex data, say for example maps, we used to none of the databases tried to handle that kind of unstructured data. So the so variety, it could be your data could be in various forms. The data could be images, data could be photos, there could be maps, data could be plain text, and all sorts of data. So that's a variety. Okay. Now the fourth pillar or fourth definition of characteristic of big data is veracity. All right. Veracity, when we call veracity, is the data in doubt. So uh, there will be, when you are churning data, transporting data, transforming data, you are doing all sorts of things on top of data. There'll be lot of points where you will feel that this data may be completely useless, whether to store this data or just throw it away. So that kind of confusions would arise. So till the point you say firmly that this data is completely useless, should we delete it? We should delete it. Till that point, we call that data in doubt. Okay, and that's another characteristic of big data. So big data could be in various kinds of structured, unstructured. Structured means of data in the form of relational databases, relational format. And when we say mm, unstructured means it could be images, videos, plain text, and it could be uh, maps, and semi-structured data means that it could be in a format like XML, or it could be format like HTML. Okay, because HTML or XML is not 100% structured data. There's not much of a relation in the data when it's in XML format. Now, so these are the four characteristics of the data. But at the heart of the definition of big data is distributed computing. Any data which you, for handling of that particular data, or to handle that particular data in time is the criteria, you require more than one computers. In those circumstances, we call it big data. Okay. Now, moving on. So these are few examples of the kind of data we handle. All right. So as a example of, because when the world is moving fast, and I mean we should be knowing a few of things like this question I was hoping that some people will answer. So those who are logged in from their terminals, they can answer this quickly. And so how many bytes are there in petabyte in a petabyte? Am I feebly audible to all of you? Those who are on the desktop who has a keyboard attached, they can answer quickly or just raise the hand. Okay. So Radhesham says that the 1 petabyte is 1024 terabyte. Feel free to answer to all instead of only the presenter. Okay. Thank you, Radhesham. Radhesham. And excellent, excellent. So, so probably all of us know that it has got 15 zeros in it. Okay, a petabyte has got 15 zeros, and and most of the existing relational databases fail to store such kind of data. Okay, even if they store, it's impossible to churn the data. And this is the table which you can glance quickly, kilo, mega, giga, tera, peta, exa, to understand how much, how is the data going. And this is where when the data starts from terabyte, petabyte, exabyte, that's where the we call it that's where we start calling it big data based on our use case. I'll further dig down. So a quick question to all of you. As I have described the definition, I have described big data. A big data is something which you can't handle using single computer or using traditional systems. So from that definition, do you think 1 petabyte data, which is 1024 terabyte of data, lies in big data domain? Anybody? Quick question. So is 1 petabyte data big data? Yes, no, maybe. Okay, good, good. Yes. So Neeta is saying that depending on various other parameters, we can say whether it is in big data domain or not. Right. So the various parameters was can you handle big data using a single computer? The answer is no. Okay. The answer is no. You will require multiple computers to even attach a storage 1024 hard disks to a network. Do you require multiple computers? And when you do that, that means it is a big data because you had to store it on multiple hard disks in multiple manner. Okay. So in general, one petabyte lies in a big data domain. Most of the existing systems can't handle it. Okay. Now it sounds that the big data is not really a big deal, and it's just one more step, right? But what I want to show you in this diagram is from left to right is the timeline. In 1986, the digital data was zero point zero 0.02 exabyte, while in 2007 was 7 years ago. 2007, the digital data, which was based on a survey by Hilbert and Lopez, the digital data was 280 exabytes. All right. So, so basically, what you see is that suddenly in 2002, the data exploded. I mean, people started storing a lot of data in various kinds of format. And that is when and why did this happen? We'll just come to that point in a minute. So here you can clearly see the analog data, analog as in tape drive, cassettes, and floppies, and I mean, floppies was still a digital data, but existing analog format of data was around 2.6 exabyte and did not increase much. It just increased to 19 exabytes from 2.6 in around how much, 20 years, 21 years. So this shows you and you can see that paper, film, videotape, and vinyl, analog videotapes, etc., lie in analog. Okay, so it is a clear evidence that digital data keeps on increasing every minute, specifically in this era, which started in 2002. We call it a digital age where the data started exploding a lot. Okay. Now, why did this happen? First, lot of devices. Now everybody has a laptop. Everybody has smartphones. Everybody is having, multiple tablets. So, and when we use any of this, we actually generate a lot of data. As we are talking right now, we are generating a lot of data in various format, like transmitting videos from my side to your side. And at the end of this session, the total transport of the data will be around 26 gigabytes, right? Because the video will be 1 GB, the video, this video transfer, and there are 26 attendees right now, right? And in my sessions, in other sessions, like I had 100 attendees, 200 attendees, there is like 200 GB of data is getting transported over a period of 3 hours. Similarly, the same data is getting recorded at my end and might have been recorded at your end. So we will be further generating a lot of data, right? So these devices which we use these days, each one of those is starting with your routers, your hubs, your switches, your all the kind of network you have, they generate a lot of data. So that, and then there are sensors, there are when you are into manufacturing, you have got lot of sensors, they communicate to a central device. Even your mobile communicate to a central devices, central servers, where they update how much you walked, how much, what's your heartbeat, all sorts of things. Okay, so other than because these devices became cheaper, okay, became cheaper and accessible, and so people did a really great things with devices. The third thing is the connectivity between people. The internet became very accessible and possible, and hence various kinds of social networks came up, starting with Facebook, Twitter, Google Plus, Flickr, Yahoo, and all sorts of things. So an individual generates a lot of data every second. People are chatting over WhatsApp. People are, I mean, so effectively, all I'm trying to say, because of the devices availability, because of revolution in devices and revolution in various uh, networks, the 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 data generation became too high. Okay, the data generation became too high, and this data can be very useful, and most of the data is actually useful, has been proved by many players in this industry. So so basically, we all are generating a lot of data. We all are generating a lot of data, and this data can be very useful, right? And I mean, the call logs, the video calls, everything generates a data. So that is why this is very important and cannot be ignored. Now, this sounded like if we could use a better computer, we could handle all sorts of data. But the truth is, the truth is we cannot handle. And why we can't handle, I want to explain to you with this slide. There are basically four things in your computer which help you handle the data. First one, first one is your CPU processor, which does the processing of data, which is the mind of the everything, which does the computation to which you order everything, and which the whole thing starts with the processor. The faster processor you have, the better it will go. Now, CPU, which means the CPU is the is plays a big role in processing the data, but CPU becomes a bottleneck when the data grows big. CPU is fine with when you are dealing with MBs of data, gigabytes of data. If you do a quick computation, that how much time does it take for CPU to churn a data of size petabyte, you will realize that it will take at least 8,000 days to handle that kind of scenario based on your requirement. I'm just throwing up a number here. So second pillar of processing or data handling is your RAM. RAM is where the CPU keeps the data and reads the data from, right? Because RAM is very fast to read from. So all the data that is being processed at a time by CPU is kept in RAM. The third one is the disk size, how big the disk you have, right? And how fast can you read from the disk. Okay. So if you have a bigger hard disk, you can handle bigger data. If you have a faster hard disk, the chances are that you will be able to handle the data at fast, because when when CPU processes any data, it reads from disk and put it into RAM. If the disk read is very slow, then it is going to take more time. The fourth one, which we keep on ignoring, is the network. So whenever we are storing a lot of data and our single computer is not sufficing, we put it on the network and then access it from there. If your network is the bottleneck, if the network is the bottleneck, then we cannot process the data. That is why the newer framework which we are going to discuss, such as Hadoop, think about all of these four pillars, all of these four things, and then they came up with a solution. When these four things become the bottleneck, how to handle how to handle the data on multiple computers, right? So since these four components, CPU, RAM, disk, and network, they become the bottleneck. So when people add more computers to the network, they are able to increase CPU to double, increase RAM to double, increase disk to double size, and and network speed also get doubled. Also, most of these systems, new generation systems, they send code to the data instead of bringing the data to the code. Okay, so these are the few aspects uh, of do we need to, what are the four bottlenecks or four components which help you handle the data inside your computer, right? And at least one of them will become a bottleneck, right? For a website like Wikipedia, disk is not a problem because the total size of Wikipedia is around um, it's within 100 GBs. Okay, so for Wikipedia, the disk is not a problem, but the problem arises in RAM. And and then once you try to solve the problem of RAM, the problem starts happening with the CPU. And that is why Wikipedia had to go with a distributed architecture or using multiple computers. So distributed architecture, I will be using it on and off with multiple computers. Okay. So no here are few of the big data customers. Here I talked about why big data matters to you. Before that, I talked about what is big data, and why is it that what is it that becomes the bottleneck? It is either four of them, or either or one or more of these four things. You will try to solve one problem, then you will get stuck with another, and and therefore when you add one more computer to the network, it doesn't become double, it might become 8 times or 16 times the whole data processing based on your model. Because if the CPU get doubled, the RAM get doubled, the disk get doubled, the network get doubled, so your data processing might become 16 times, right? So now here are some example use cases where we deal with big data. So first one is the retailing part. In general, the Google and Amazon, when we say web and e-tailing, so people like Amazon and Google, the first and foremost use case in this is recommendation engine. As per Amazon, most of their sales happen because of their recommendation engine. Recommendation engine what? When you go to Amazon, you click on a product and the product details come up. And if you scroll down a bit, you will see that people who bought this also bought this. You may also like these products. You may also people who like this product also like this product. So that is the recommendation, and that helps you build beautiful system. I mean, that helps you make maximum number of sales, and that helps your users to make a great purchase decision. So those are called recommendation engines. So that is the first one, and that's a like prominent one in this game. For example, Netflix is a movie rent website. Sounds like a very small website, but what they do is they provide you with a movie rental, right? And for a movie rental, if they can recommend you that you like these movies and hence you will also like these movies, okay. So recommendation engines are everywhere actually in today's time. And in recommendation engine, the other word we use in the technical terms is called collaborative filtering. Second problem, so these are not something which is not happening. This is what everybody is using in today's time. Say for example, at InMobi I built a recommendation engine for them. At Amazon we are already had recommendation engines. Similarly, Netflix is already using. So almost everybody is having recommendation engines as of today. And the key point when we talk about a recommendation engine is that most of these recommendation engines are built on top of petabyte of data. Even the rudimentary one which I built in around 20 days were churning 200 terabyte of data. So in case of Amazon, it is far more than 200 terabyte of data. So most of these recommendation engines actually churn petabytes of data, right? So second is ad targeting. Most of these companies use, because they have a lot of real estate, lot of ads, and at the same time, lots of people playing games. So playing games on the phone, and they have to show the ads. So ad targeting becomes is a big data problem. So most of the problems are, when you handle a bigger data, even as simple as counting number of lines in in some petabyte of data becomes a big data problem. Okay, counting the lines in a petabyte data is a tedious thing. Similarly, search quality improvement. So I remember my days when I was building this document management system, and L&T Power is one of our customers for that product called T-Bits. Now, this product, when we were building search, we saw that there's a lot of scope of improvement. It is not as simple as it sounds. Though my data was small, my data was hardly 80 GB in size. In, after 3 months, after 3 months of in operation, the data grew up to 80 GB, and it kept on increasing linearly, right? So So for search quality, I realized that we need to churn a lot of data from internet. For example, when people search for blue dart, okay, or people search for L and T, what are the various combinations they use? They might use Larson and Toubro. They might use L space ampersand space T. They might use L A and D and then T. And there are lot of such combinations. And there are millions of such words people are looking for. I cannot keep on feeding these words all the time into my document management system as plurals. So instead of relying on uh, our own churning, our own data churning. So what I did was we went to we found out a lot of data from Google's and Amazon's, and periodically we intersected that data with the data we had, which means that we knew the plurals of the data which we are storing. Of all the keywords which we have in our data, we had the plurals from all over the world, right? So say for example we are storing, we have a keyword in our data called hard disk. Okay, hard disk can be written in many format: HDD, and then HD drives, then disk, and hard disk, and then there could be space. So all of this was given from or taken from the Google and taken from the World Wide Web, and we figured out these are the aliases, right? So that is sounds like a very rudimentary problem to solve because we don't have big data right now. We have like 80 GB data. But the moment we included plurals by searching the internet, by figuring out the patterns in the words, we we realized that our search has grown far better. Okay. So those are the search quality. Search quality is actually improved to a very large extent. Right. Similar is the sentiment analysis for almost every organization, be it L&T, Infotech, be it no big data. For everybody, they need to keep track of what people are saying about them, or what people are talking about their newly released product yesterday, and how is their popularity grown after launching this product. What is whether people are talking positive, whether people are talking negative, right? So those are the called sentiment analysis, and sentiment analysis is probably the part of every marketing strategy in today's world. I mean, at Amazon we always as soon as we launch a product, a new fresh range of products, we used to monitor the sentiments of people all across the globe, not only on Twitter, but all across the globe. Doing sentiment analysis on Twitter has become really commonplace. So, for example, that whenever you launch a product, before launching the product, you will go over all the tweets about yourself across the whole Twitter. Twitter provides you the whole data. And after you have got all the tweets from the Twitter, you will you will figure out that what are the negative keywords used with our data, with our brand. And now using a bit of a rudimentary analysis, you can simply count the negative words used with you and count the positive words used with you. Now most of the people will say that we can use that this is not this doesn't sound very bad. Okay, so if somebody is using this kind of phrase with our brand, he's actually saying bad things, okay, good things, but using two negatives, right? So in such cases, these are if you count all number of positive words and negative words, and those words are in millions and numbers, most of these outliers, such kind of sentences are are quickly overshadowed by other numbers. Therefore, a big data matters because in case of big data analysis, most of the insights make sense. If you have smaller data and you are trying to do a churning, you might end up with special cases or very very narrow form of analysis. So these are few examples of big data use cases which people had been using day in day out for years. Abuse and click fraud detection, this is what I was doing when fraud detection is what I was doing when I was at DE Shaw around 10 years ago, 12 years ago actually. There we were doing lot of fraud detection based on patterns which we figured out from the transactions. Like for example, when somebody does a credit card transaction beyond a certain amount multiple times quickly, there are high chances that this person is doing fraud. And this we figured out based on lot of data. Similar kind of pattern we had figured out. Okay. Say, for example, a person who is logging in from a certain IP, which is located in US, and he's using a credit card from somebody in South Africa, there are high chances that this person is doing a fraud. So this kind of analysis, which required a lot of data churning and figuring out pattern, is only possible if you have a big enough data. If you have, say, thousands of record or 10,000 record, it does not make any sense to do much of a data processing on top of those records, because you might end up with having wrong insights, right? Therefore, the bigger the data, better the analysis. And therefore, it is very important for storing and being able to process the big data. Similar is the case with telecommunications. And in telecommunications, as I see a lot of people coming from telecommunication into our classes, almost everyone has been asked by their organizations to study the big data, so that they, because they have couple of almost every telecommunication is coming up new big data projects. So, and some of those are like examples are customer churn prevention. Customer churn prevention, as in people should not be leaving you, and the moment they are leaving you, you can see their call record and figure out what is the pattern. Was our connection dropping a lot in their area or not? What was what happened to their last three calls? Did it break badly? Were they not able to connect? So those kind of problems, if you can figure out, then you can stop your customers leaving you. Okay. A website like ours, like KnowBigData, we still have like around 20,000 visits. That small number itself gives us some decent insights. And for companies like L&T Infotech and others, that could be a very big deal. And then most of telecommunications improve their network performance based on various kinds of data. Okay. Like for example, people have figured out in case of days, the in case of daytime, the traffic is high on the business park sites. So therefore, the capacity, they need to do a capacity balancing, right? So these are few examples of big data. In government, a lot of fraud detection, and then security warfare and welfare, and then even for justice people use it. Healthcare and life sciences, it is has big data has been a big boon, because most of the information in say gene sequencing, it requires a lot of processing, and supercomputers, even supercomputers were not able to do it. Supercomputer is no longer a faster computer. Supercomputer is hardly few times faster than your normal laptop. So therefore, uh, and we needed to process this kind of data, we need at least 100,000 times faster computer than your laptop. And therefore a big cluster of nodes solve their problems. And this is being done. I have taken all these examples from the Hadoop's website, and they are using it very well. Okay, now is the time for question answer. And here are like few common myths which I keep on listening. And so, for example, people say that big data always means data above in the range of terabytes, right? My question is that even 1 gigabyte, say 100 gigabyte of data, might become your big data, because there are chances when you try to churn 100 gigabyte of data, there are chances that you might get stuck and you may not be able to make any progress using a single node, single computer. Is always about social media? The answer is no, as I said. Will replace enterprise data warehousing? No. So enterprise data warehousing is great solution for organized data, for transactional data. Okay. And most of the solutions which are built for non-transactional data, right? So it is very, very difficult to have the transactional information in the big data solution, because none of the big data solutions have been targeting transactional data, because transactional data is anyway being handled by data warehouses or existing databases. It is just a buzzword, no practical application. No, the answer is that it is not a buzzword. I have seen three companies, and I have used at three companies, all of these big data technologies and there was no alternative actually. Is a new concept? No. The answer is because I have been using this for more than 12 years now. When I joined Disha, the first project was to do a fraud detection, to do anti-money laundering on top of 10,000 computers. Okay, because on a single node it was taking couple of days. Okay, therefore I had to figure out a way to solve the problem using multiple computers, and we had a 10,000 node clusters. So it's not a new concept. Will be the future? The answer is that it is the present. It's not the future, it is the present. Is expensive? No. When we talk about expensive, there are two parts to expand, the price. First is the software, second is the hardware, and third is the technical abilities, the technical manpower. So all these three things, out of all these three things, the only thing as of today is the manpower, which is costly, because hardware, the way most of the big data solutions are built for the commodity hardware. And with respect to software, almost all of the big data solutions have a open source free counterpart. Okay, and they charge only for their service. So they are really, really cheap as compared to any Oracle, MS SQL, or IBM's, right? Although IBM has their Hadoop, their version of Hadoop, is only for data scientists or is magic? No, it is not for data scientists or is magic, because it has become fairly simple for everybody to start using. And we have enough hardware and we don't need more. This is another deal. So when you when you set up a cloud, or when you are setting up your cluster, you don't necessarily need to buy a new hardware. The way most of these tools have been built is that all these tools can run on very, very minimal hardware or any kind of hardware, right? So you don't need to buy a new hardware. You can utilize the existing systems and to build your cluster. We will build it when we need it. The answer is no. It goes in opposite direction. First you build it, then you will be able to use it. If you never build it and you wait for the time when you need it, that will never arise, because whenever your engineers are trying to solve a problem, whenever they are trying to store big data, say petabyte of data, they'll have this mental block right now that we can't handle this kind of data. Let's just delete the old data. Let's just keep this 1 month of data. And that's why you will never build it, because you will be under the illusion that you are able to solve your problems. And the last one is, big data is all about Hadoop? The answer is no. There are hundreds of other solutions which have come up. Even I mean, starting with, even Microsoft has come up with the great tools, and there are variety of tools available today. It's not about Hadoop. Hadoop is just one one solution which does it. There are hundreds of similar solutions. So these were the myths. And how is this analysis of data saving money for business? So this is a very difficult question to answer for lots of us. But for those who have used analysis of data, they can clearly see it. So, first is that examine our assumption before build the product. This was the single most important criteria to build, to have a big data analysis in place, right? If you have any product, you will have the history of all the users from all across, and you will know that who needs what in that which geography. So that will give you a clarity before building the product. Second, evaluate your sales and marketing strategies using your big data analysis. So, this is the job of a product manager or a marketing manager to figure this out based on the data. Whenever in your doubt, you should be able to utilize the data to clear the doubts. And this is something which we did a lot at Amazon. Even figuring out whether to keep the submit button blue or red was decided based on the data, based on A/B testing and historical data analysis. And where are our servers failing? Everything was data driven. Data guided us that, hey, this is the pattern when our servers are about to fail. And this is the pattern when our customer is going to buy something. So, data actually helps you make money and save money for a business. What is the expense of big data handling? The answer is it's very, very cheap. For a person like us, like KnowBigData.com, we are running a around 20 node cluster right now. And a lot of our students, researchers, and a lot of organizations who are building their prototypes, they are using our clusters to to build their solutions. And it's very, very cheap. So most of this, this is generally an illusion that big data handling is very, very costly. So effectively, what I'm trying to pitch in is that big data saves a lot of money or makes a lot of money for businesses. Okay, and this is another one. So generally, when you figure out that people are starting to use a technology, you generally look at the trend in the jobs, and when you see the talent, how is the talent available in the market, that is decided upon salary. So this distribution shows that there are so many jobs available for big data guys, which means there's a huge demand and people have started using it already. And the second graph shows that there are people, the people with the Hadoop background get paid higher than the other one, which means there is a scarcity of talent in the industry, which means that people have already started using all of these technologies. Okay, so this is just to clear up this this thought that big data is, it doesn't matter to us. Big data is only for big guys, or big data is not our problem. Okay, because we are not going to handle it. Then, if you go through the Gartner's top 10 reports uh, of 2014, all four points, first, fourth, ninth, and 10th point relate to big data. Similar is the four top Forbes top 10 technology trend. The point 5, 6, 8, 9, all of these 4 points belong to the big data, which means that it makes a sense to uh, you know go into the big data field, and people need it a lot. All right, so now is the time for question answer. So Neeta's first question is, depending on the other parameters, we can say, okay, yeah, Neeta, ask your question. I'm waiting. And others can raise the hand. Those who don't have access to the typing right away can raise the hand, and then I can ask. I can answer your question. Himanshu, Jatin, Mangesh, Mrilanali, Neeta, Pranjay, Radheshyam, Sandeep, Shanmuga. Okay, great. We have got a uh, you know, great audience today. Yeah, Nita, I'm waiting for the your answer. Should I mute you, unmute you? Okay. I thought you were. Okay. Right. So Nita is saying that I disagree regarding cheap cost of big data solutions. There is support needed for Hadoop and other application, and licensing costs need to be paid. So first, right. So right. So let me explain. So I talked about three parts. First one is hardware. So hardware is commodity hardware. Second, software. Software, if you compare the licensing cost of the existing product, is really, if you don't want a license, don't take a license, right? I mean, if you have a technology expert, if so, only the third aspect which I feel, the third aspect is the the people, right? People, you can groom people into big data technologies, and that's the grooming part is only the cost which I foresee. Okay. Most of the existing talent which is there for relational databases, for data warehousing, all of them can be groomed into handling these new set of tools, and therefore you don't really require to take a license. I mean, if you do not like to have a big license, then don't need to have the license. That's as simple as that. And there are multiple players for Apache Hadoop, and you can compare their cost with MS SQL or Oracle, and you will find that the solutions are cheaper. The only problem is the right now the experts are scarcely available, and that will be solved only if people move into these technologies. So partly you are right, but if you do a comparative analysis, you will find that it is the talent which is the costliest as compared to the other technology as of today, and that will be happening. They'll come down over a period of time. And also, as the talent comes up, all these small technology companies who are charging too high for a license, the support as of today is very highly overrated. Okay. And therefore, as the talent comes up, more and more people are learning every day, and this whole phenomena is going to come down anyway, right? Yeah. Example is cloud era, and therefore companies like Hottenworks came into play, and they are doing a far better job. They're giving a cheaper solutions, right? Similar was the Teradata was charging a lot, and then Cubole comes into play. Cubole, they are doing a great job. Altiscale is doing a great job. So there are lots of companies every day coming in, and there's a competition rising in. And since not a single person is holding a patent on the whole technology, therefore multiple players can enter, and people like us can also enter into the domain, and therefore it is going to grow uh, cheaper than all other technologies. So okay, yeah let me answer Vivekanand's question. How big data is being stored is any file system or any other medium. So I will discuss in detail this part, but for now the data actually is stored using your existing file system. It is just that there is another system which slices your data into small parts and stores it onto multiple machines, and then when you access it, it gives you back, right? So the actual storage remains exactly the same way, but the way you interact with your files changes. And we'll go into the details very soon. Nothing to worry on this. Yeah, Suchita, does Hadoop cluster have analytics tool? There are, let me answer Suchita's question. So there are multiple kinds of analytics tools available as of today, starting with new breed of tools such as Pig, Hive, and other similar tools. you can, after you have converted your big data into small insights, which are possible to present using your existing tool, you should be able to use your existing BI tools. There are drivers which connect to these servers. Okay, so if you have a Crystal report, or you have Oracle's, I forgot the data viewer's name, and if you have open source BERT, business intelligence reporting, you can use any of those solutions and present your report. But to analyze the big data, say you have got 300 terabyte of data, and you want to build a simple insights like the distribution of XYZ over a period of time. So once you have converted your data from thousands of terabytes into say hundreds of MBs, then you should be able to use your existing systems. And that kind of translation is done through languages like Pig, PigHive, and we cover the PigHive in this session. Okay. So presentation and everything will remain as is. It's just the translation from 100 terabytes to your 100 MB will be done using uh, solutions like Pig or solutions like MapReduce. Okay. Now, what is the difference in the role of data scientist and Hadoop developer? So data scientist's role is mainly to figure out patterns in the data and build a new set of algorithms, while Hadoop developer can use those algorithms, instead of understanding the whole statistics, because a data scientist knows a lot of things, like starting with various kinds of techniques, data analysis technique, statistical techniques, and R and Python. The Hadoop developer knows how to take those insights and present them to user, or how to take a huge data and run those algorithms on top of the data. Okay, so most of the data transport, data translation, and data summarization is the job of Hadoop developer, while data scientist job is to figure out new algorithms in this arena, or fit an existing algorithm on your data. So now next question is, also we want to know the limitation of big data. Limitation of big data as in big data tools or big data technologies. We want to know the limitations of big data. So first of all, there is a few areas you need to figure out. Where I'm trying to understand your question. Your question is, okay. Let me. So I will just unmute Pawai's. Just let me answer these questions, two questions, then I'll. So right, we want to know the limitations of big data. So basically, your question is that what are the use cases when these solutions which we just discussed are no longer valid, right? Uh, where we should not be using big data tools. So first, when you are dealing with your transactional data, right, your bank account transactions, where data has a relation with the other data, and even a slightest change is intolerable, slightest correlation breaking is intolerable, right? In those circumstances you should not be using any of these big data tools. Second, if your solution can be solved using a single computer, an existing solution, do not use any of these big data solutions. Because if you are able to use a single node or single computer to churn your data, right? If you divide that onto multiple computers, it will actually slow down rather than making it faster, right? In lots of circumstances where data is small, because there is a lot of communication required between machines. Now, let me, okay, great. Sunita's second question is, what are the skills needed to support big data and Hadoop? So this particular course, this course covers up almost all the technologies required for a Hadoop, tech, big data and Hadoop development, and you should be able to handle it. The skills are required for learning this course is basically you should be okay with SQL. You should be okay with the SQL. You should be okay with any operating system, and you should be okay with the one programming language, be it PLSQL, be it any other mechanism. All right. So be it any kind of language, even if you are okay with the COBOL, then it should be okay. Because at some time I have tried to explain the new language called Pig Latin, and I have observed that those people who have done any programming even during their college time or even as a hobby, they are able to handle MapReduce and Pig very very easily. Okay, but that's very secondary issue. Even if you are okay with basics of any programming language, how loop and everything, then it should be good. Now let me. Okay, great. So yeah, so I will be unmuting the Poway team, and then we will go ahead with others. All right. Okay, I can't really figure out which one is Poway team because all are LNT Infotech. So there is one. Okay, great, great. So Poway team got the answer, so we don't need to unmute them. And okay, how secured is big data to store confidential and valuable information? So that's Vivekanand's question. So most of these solutions are getting secured. They are not as secure as they might look like in the beginning, but lots of them have got secured recently in past 1.5 years. Right? For example, take a case of MongoDB. Most of the data is now encrypted on the disk. Similar is the case of Hadoop. But the prime concern with all of these systems was not security. Prime concern was that your cluster is secure, but you have secured your cluster, but it's not. I mean, there are high chances that people might, you know, mm, stamp on each other's foot. But since it's the whole philosophy is on top of big data, on top of Linux and Unix, so it's as secure as Linux and Unix or your Windows is. Okay, I'm talking about Hadoop. So one question is, can Hadoop be installed in Windows or Unix OS? It can be installed on either of them, and you can have the hybrid also, meaning some systems with Linux and some systems with Windows. Earlier, a few years back, it was not possible, and therefore Microsoft Bing itself was using Linux systems to use Hadoop and these big data solutions. But now Hortonworks and HD Insights team from Microsoft, they have done a marvelous job, and now Hadoop really works well on Microsoft's platform as well. So it runs on almost on all kind of servers, starting with Mac OS, Linux, Unix, and Solaris and Windows. Okay, and it can be ported to any system because Hadoop is basically written in Java. Okay. Now, all right. So, was I able to answer your question? Okay. So, in case you want me to unmute you, just raise your hand. There must be some way to raise your hand, right? Or it's not there. I think it is not there. Great, great. So, any other questions other than this one? Okay. Okay. So basically, we talked about what are the various use cases of big data, what is big data, why we are talking about it now, and what are the various general problems which people solve. You can come up with your own kind of solutions. Like I'm working with couple of companies from I'm working with various kinds of industrial problems, and every day I see a very innovative use of big data technologies. And some people are trying to figure out a correlation between the temperature and the stocks, for example, stock market. And these are interesting big data problems. So, and so what are the good resources to start on big data or Hadoop? Are there any good forums to learn? So there are a lot of online resources. There are a lot of online resources available. If you go to Google and try to search, there's a lot of online resources, but most of the knowledge is dispersed here and there. So you might have to work a little bit hard, or you could join our one of our trainings, and then, I mean, that's all I can say. Okay. So if you are looking for books, there are different books for each topic. There are some good books, but most of the books get obsolete very quickly. Okay. So for Hadoop, the general good book is the definitive guide from Hadoop, I mean Big Data Hadoop. Okay. And other than that, actually, a better thing to do is go through the manuals from their main website itself. The other thing which you will require other than books and manuals, maybe you will require a good setup. And exactly for the same reason, we have done a good setup for all the students so that they can do the hands-on a lot. Okay, now we have got a good question. Can there be scenarios where transactional data have unstructured format as well? So yes, so your question is very valid. So let's take a case of say you got a lot of users scanning their bank statement and uploading onto your system. The data is transactional under the hood, but the format in which the data is coming in is not transactional. I'm reading out L&T Infotech's question. So feel free to send these questions to all so that I'm just reposting their question, right? Because let others also read that. And yeah, so yes, so there are lots of circumstances where the data is unstructured format, and it is a transactional data. That happens a lot in lots of cases, right? So one example was the bank statements I gave you. The second is that say you are running say Google AdWords. In Google AdWords, the moment user clicks the data, clicks on a link, the person who is showing the ad has to pay to Google based on a bid, right? So initially, this when the user clicks the data, clicks on a URL, it is just a log in their system. One and every few minutes or every few hours, they process these transactional log and convert it into a relational data, which is smaller in nature, right? Can there be scenarios where transactional data have good, but so was I able to answer your question? So no SQLs cannot be used instead of relational databases in very honest opinion to you. They are not really a very great alternative to relational databases when it comes to transactional data. Most of these NoSQL databases handle handle the structured data. So there are two keywords here, structured and transactional. Transactionals as in when you add a record and then you add another record, if they both are in transaction, both should roll back. in case any of them fails. Okay, that kind of guarantee is not possible in case of any of the NoSQL databases. While NoSQL provides you a great structure, right? So NoSQL can be used to handle your structured data, but cannot be handled generally for transactions. People are working on it, and some of the databases try to give you a guarantee of transactions, but most of them fail to do it because of the I mean there's something called cap theorem which says that all three things cannot be guaranteed: consistency, availability, and having a cluster. All these three things cannot be guaranteed. I'll go into these details maybe in one of the sessions where I describe HBase. Why can't it happen? Can JSON kind of format handle both structured as well as non-structured data? Yes. The answer is yes. Okay. But it will not be that great relational data. Relational is structured, transactional. They have a slight differences. So even though you have JSON, great JSON, but lot of times, say for example, MongoDB, we store everything in JSON, and still forming a relation becomes a difficult. Is not as straightforward as relational databases is, but it does a great job. It does a great job. No. So MongoDB itself, they don't guarantee a transaction. There are hacky ways to build transactions, but they are not as seamlessly transactional as are your relational databases. Because the moment they start to become transactional, their performance drops really bad. The performance of such system becomes equivalent to relational database, and therefore none of these systems try to be transactional in nature. So in case any of these databases starting with Cassandra, MongoDB, or other systems, in case they try to be transactional, their performance drops very badly and they become like a relational database and on a single node. And that is the reason I'll give a good UI. So what is the alternative to Hadoop from Chennai? Okay. So from Chennai, there's a question. So alternative to Hadoop, there are multiple systems for specialized systems. And let's take a case of MongoDB. If you just require a way to store and process the structured data, then MongoDB would might suffice your need, or a Cassandra might suffice your need individually. Cassandra is also a database, but I mean, none of the ecosystems are as complete as Hadoop is, because Hadoop has got almost every kind of components required for big data processing. Was he able to answer your question to Chennai team? Great, great. So let's take a break for 15 minutes. Let's come back at 11:45. In case you have a question, you can, write that question down by that time. Is Java a prerequisite to learn Hadoop? The answer is no, and it depends on courses from one course to another. The way I have tried my best to create a whole course, I have made sure that people from non-Java background should be able to sail through all, and for that matter, almost all the candidates. There had been only 1 out of 20 candidates who did not know Java, and they had been able to perform really good. There, there is only one case, which is MapReduce. Most of the people try to write the MapReduce code in Java, but MapReduce is more like a paradigm instead of a library. Okay, so that paradigm can be used with shell, your binary, or your Python, Perl, or maybe C sharp. So almost all the languages can be used. So Suchita's question is Hadoop like a Java or PLSQL? So Hadoop is basically an umbrella term which is used for many kind of systems. Okay, and you will get your answers when we describe you in the second half. Right? That's probably the next slide. Just next slide you see here, it'll give you answer. Okay, so this next slide will give you the answer. All right. So let's come back at 11:47. Take a break of 15 minutes. Now it'll be 48. Okay. And yeah, Bangalore team, I'll answer your question after coming back. Okay. Let's take a little break. Hi, I'm back. Are you guys back? Should I start now? 15 more seconds and I'll start. All right. Okay. Okay. So should I start now? Great. Okay. Okay, starting now. So let me first, before starting again, let me try to answer Aarti's question. Aarti has got a very brilliant question. She says that when our solution fails on one machine, we add one or more machines, and then our solution will work. Then we can say that our solution is for big data solution. Very correct. So you have invented your own way of doing a distributed programming, right? So and you are basically handling the big data. Yes. Then we can say for volume and variety, volume and velocity characteristic, this is understandable. However, for the variety, what is the use case for which we need multiple machines? So very brilliant question. So first I have two answers to this. First, those people who came up with these definition of 4 V's, they are adding 1 V every year. Okay. Earlier there were 3 V's: velocity, velocity and volume. Then they added variety. Then they added veracity. So now there are 4 V's actually. So first they must have not thought about this much, right? Second is, in certain circumstances, take a case of, for example, finding a way on a map from one location to another location, taking into consideration the traffic and other details such as how many tolls are there. So in to solve such kind of problem, which are basically a different kind, uh, it's basically on a non-relational kind of a data, which is a map. You will require multiple machines parallelly to solve your problem. Okay. And that is the only use case of variety I can think about. Okay. Similarly, the other use case could be, say you have got say 50 GB of videos, okay, and you need to convert this video from one format to another, and you need it in couple of hours, in say at most it should take 15 minutes. The best way to solve this kind of problem is to distribute onto multiple machines, and hence variety also forces you to to use multiple machines, because for processing video it takes a lot of time. Although had it been a plain text, or had it been a relational data, it could have been taking like maybe half an hour to process on a single machine. right? So that is the use case of the variety where you might require multiple machines. But to be honest, I mean, I'm being very, very honest with you. This definition of volume, variety, and this thing is great to know because people expect you to answer in that format. But at the heart, it lies the multiple machines or distributed computing. Now, from Chennai, the question is, will big data become an integral part of the common projects in enterprises? Will it be a skill which will remain niche, rare, or will it become as common as spread as Java? Is there a problem? Okay, so there are too many questions. So first one is, my answer is yes, it will become an integral part of common projects in every enterprise. Other than having an enterprise data warehouse, people will have their own uh, clusters to process the data at a large scale. And then once they have converted the huge data into their structured and organized format, they move it to their relational databases. Will it be a skill which will remain niche, or it will become as common as Java in few years down the line? Okay. Is there a problem in growth and acceptance of big data? The only problem which I foresee is the inertia right now with the existing organizations. Okay. And the other problem with respect to big data acceptance is the vision part, where lots of people are not able to envision what is the use of big data, right? So the moment they figure out a use case and they have trained their people to set up a very low cost cluster, they can start to see the outcome, right? So that why hasn't it become integral part of every huge project? So basically the answer is very simple. Same thing, inertia. we have been used to we have been very used to the phase where the disk, the cost of the disk or cost of cluster was too high, that we wanted to move our data out as soon as possible. We only wanted to have a small window of maybe 1 month, 2 months, 1 year to process our data. So we have built that psychology that the disk the disk or storage is costlier than the results our data will give us. And that is why and that is one of the reasons why it is taking a little bit of time in acceptance. Okay. Now there was one question which I have missed. Is it similar to Tableau? Okay. So the Tableau is, it is not similar to Tableau. Tableau, as per my understanding, is a company, is a product, a commercial product, which is basically gives you the visualization of the data, right? Visualization of the data, similar to any other data visualization tool, right? So it does not, none of the Hadoop component gives you visualization of the data. They handle the data backend, and you use these kind of Tableau and other kind of software to visualize the result given out by, say, Pig or by Hive or by any MapReduce. So Hadoop basically churns and stores the data. Okay, almost all the components of Hadoop are of that behavior, right? So this completes our QA for the first half. So I'll be starting the second half, in which we will go into the details, in which we go into the details of what is Hadoop and what are the various components of Hadoop. Okay. So Hadoop started with couple of engineers, basically dog cutting, trying to build his own hobby project, and he was trying to build a search engine as part of his hobby project. Now, when he started building a search engine just as a hobby part-time project at home, he he was not able to scale up. After few terabytes of data, it was not possible for him to manage the data after some time. And that very time, Google published a paper called Google File System, GFS, Google File System. And at the same time, after some time, they published another paper called Google MapReduce. And the third paper was Bigtable. And based on these papers, a dog cutting implemented the file system first and made it open source and public, and used that to build the Nuts search engine project. Okay. And this whole thing was, so that was the history. The other reason is this yellow elephant you see with Hadoop is basically is a toy with which the dog cutting skid was playing, and therefore, and the toy's name was Hadoop, and therefore the whole icon and the name comes from, right? It's a cute little yellow toy elephant. And the overall objective of Hadoop is basically an umbrella term. They they house the products which are reliable, scalable, and for distributed programming, distributed computing. And almost, I mean, not almost, all of the components under the umbrella of Hadoop are of the open source license called Apache, in which you can use the product as is in the commercial space as well, without having to worry about the licensing and anything. So in case you don't require support, you can right away start using Hadoop without any liabilities in the organization. It's like Apache web server. Okay. And that gives a great kickstart to lots of development teams to start using it, right? And I mean, that is the beauty of the Apache open source license. You start building the product immediately, and at the later point of time, if you think that you may require a service, you may buy a service from some company, but you have no liability of license from anybody, right? The other quality of all of the Hadoop project mostly is that most of them are written in Java from bottom up, right? So that it is widely acceptable. So I will go into the various components of Hadoop. I'll describe the overview of all of them, and I will go into the details of two. One is HDFS, other is MapReduce. Okay, and rest of the things I'll just go into one liner. And this is pretty much covers. Other than this, we have, I mean, we cover all of these components as part of our course, this 10 classes course. This class is first class of our 10 classes course, and in these 10 classes we'll cover all these components plus few more components such as Zookeeper and Apache Spark, which came up recently. Okay, now, so first of all, let's talk about the base of the whole thing, the the root of the whole game, which is the file system. So first component, which does not depend on another components, on which all of the other components depend upon, is Hadoop file system. It's basically a file system in which every other component will be storing the data. Now, most of us have a question about why do we need a new file system when we had already great tools. So let me take you through an example. So if you have 100 terabyte of data, how are you going to store it? Here is just 100 terabyte of data, nothing more than that. And as a note to all of you, that maximum hard disk you can use is 1 terabyte of data. 1 terabyte of hard disk space. So you have got, say, right. So this is first problem which you face in an organization, that you have got humongous data. Now how to store it? The traditional way of doing it is building a network attached storage or a storage area network. Okay, say have 100 terabyte drives and make 100 and then connect these either using multiple computers or using multiple cases with a and single computer. But at the end of the day, we will form this kind of a structure. There is a main folder, there is hard disk 1, hard disk 2, up to 100. So this is how we used to do when we use any NAS or SAN, right? Now there are few problems with this kind of approach. Now, what I mean, you will feel this problem in a better manner if you visualize that. Say you have got 1,000 movies. Each is 500 GB, you know, half GB size. Now, so you have got 200 movies or so, not 200 movies. You have got 1,000 into 10, 100, which is 100,000 100,000 movies. So you have got 100,000 movies in your apartment or in your organization, which you need to store somewhere. And for that, you need to build a storage. So what you did was you uh, got 100 computers, or say 50 computers, put two hard disks in each one, with the two hard disks as backup, with a kind of local backup, RAID backup on the same one, and then you build this structure. This is a common way of building any storage area network. So whenever somebody looks at a folder, they can see that there are so many subfolders, drive 1, drive 2, and so on, and then they can keep on putting the movies in them. So there are few problems associated with this. First one is, in case one of the hard disk fails, even if, or one of the node fails, even if they have a local backup, people will not be able to use it, right? Because if the computer goes down, the network goes down on which the hard disk is attached, other people will not be able to use it, right? Se- Second problem is that how would you, which movies will go into which computer? That will become a big issue, right? Because you do not know, you have no way to figure out which alphabets should we allocate to which folders. Had you been in, if you remember your college days, where you used to struggle with keep on moving movies from one hard disk to another, or moving to one place to another, just to make space, right? And you keep on continuously changing that, okay, movies from this fold, this alphabet to this alphabet in hard disk 1, and this to this. So that distributing the data uniformly becomes a very huge challenge. Then the third problem which you will face is that, is it the best use of money? 1 terabyte is not, we already have an organization 100 GB hard disk, 200 GB hard disk, and 500 GB hard disk. Can we utilize those? Now, the last point about the whole thing is that increasing accessibilities. Oh, oh. Is my voice clear to others? Okay. So, okay, okay. And my question is that, Mrinalini, only the Pune team is probably the voice is breaking for Pune team, right? So if there's somebody who can take care of that part. Okay, okay, great. Now the last point which we all ignore is increasing the accessibility, right? Say we put, there was a new movie released this Friday. I mean, DVD came into market. You brought it and put it in a folder or in one computer. And note that these all folders are on different computers, right? So new movie released and we put on, say, drive number 100. Now everybody in your apartment or in your whosoever in your users will be trying to watch the same movie, and the 100th computer will go boink, right? Because of the network will get throttled. Everybody's trying to read from that. The CPU will get throttled, and this will go blank, and hence none of the people will be able to watch it, right? So It's such a common kind of a problem, right? Being able to build a central place where people can store the videos and watch it. To do that kind of thing, even build that kind of tool using existing systems become really problematic. Accessibility is one such big deal, and therefore, after thinking through all of these problems, uh, Google guys came up with something called Google File System, and Hadoop guys adopted the same mechanism. Now the question is, how does Hadoop do it? Right? We'll talk about those details. How does Hadoop solve these problems then? Right? We'll talk about these in a minute. Till then, I'll just like to take you through the compute engine part. Compute engine part, basically, if you have to do a lot of computation, or say, for example, you have to sort your data, and sorting the data using 100 computers or 1000 computers can give you results in a minute, as opposed to doing the same thing using a single computer. Right? We'll go into so MapReduce is your compute engine, and now Apache Spark, which has come recently, is also the the new age MapReduce. Okay, the compute engine. So basically, the compute engine solves your problem by running your logic onto multiple machine, while HDFS, which we discussed, will store your file onto multiple machines in such a manner that you can, providing you a great failover, great backup, and great accessibility. Right. So that is the role of MapReduce. That was the role of HDFS, and the role of MapReduce is anything you do, starting with select star from my table and group by this and that. That is processing, right? Being able to execute this query on multitude of data, which is located on multiple machines on HDFS, is is given by MapReduce to you. Right? Now the third one is NoSQL database. So HDFS provides you simple file storage, just like any of the NTFS or FAT32 and all that. I mean, so that kind of storage, plain vanilla file system is provided to you by HDFS. On top of it, if you want to organize your data in a structured format, then HBase is your solution. HBase is a NoSQL database. NoSQL databases basically mean that your data will be stored on multitude of machines, and every table will have an ID column. Every table will mandatory have a primary ID, because based on that ID only it will be able to divide the data and keep it somewhere. So that's a common characteristic of any NoSQL database. And HBase is one such NoSQL database where you can store a lot of data. Lot of data means billions of rows into millions of columns. Remember the millions of columns. Most of the relational database did not worry too much about columns, they worried more about rows. But here, NoSQL database, they try to handle really huge data. And such kind of database, such as HBase, is useless to you if your data is smaller. If your data is say you know 1 million rows and then few hundred columns, then also HBase is not a great solution for you. Okay, HBase is great for above 100 million by 10,000 kind of rows. So he really uses data. So this is the database, NoSQL database, which we will be discussing in one of the sessions. And these are all parts of the Hadoop ecosystem. All right. Now, compute engine, when we talk about, you will get a clarity of thought when you think about how much time will it take to order the data, 1 terabyte of data. 1 terabyte, say 10 billion strings, and each string is 100 character long. How do you sort, and how much time will it take to do it on a single computer if your RAM is 2 GB, right? So the answer is 5 hours. For me, it took 5 hours when I did a lot of engineering just to solve this problem. But it will take maybe a day for you using any of the relational database. But even this 5 hours is not acceptable at a lot of places. We need to be able to sort the data. So I'm just taking sorting as a single example, because sorting is a form of processing the data, which is the most common one, which is the most common form of processing the data. When you do in an SQL, when you form indexes, that's a sorting. When you do group by, that's a sorting. When you join two tables and look up in indexes, that's basically is utilizing the sorted data. So sorting is the heart of almost any processing. Therefore therefore I'm trying to interchange the keyword processing and sorting here, right? Although processing might include looking up in the map, but most of the big processing problems can be broken down into sorting problems. Sorting as in ordering the data problem. Okay. So most of the problems can be solved easily by if you by implementing a really good sort. So to sort the data, MapReduce is one. The MapReduce is one key characteristic is to be able to sort the data very very fast. Other than distributing the processing, using the distributed computers, say thousands of computers, MapReduce is able to sort the data really really fast. As an example, Google was able to sort 10 petabyte of data, 10,000 times the data which I just sorted, using 8,000 computers in 6.5 hours, right? Using 8,000 computers within 6.5 hours. And that is the benchmark, the industry tries to achieve, right? So sorting is one such game where everybody is competing. All these big data companies are competing. Okay. So this gives you an idea, because thinking about 10 petabyte data, none of the existing database can do that, right? None of the existing database can actually do that, right? And that is a kind of thing, and Google did that on MapReduce, right? So Umesh's point is correct. So you can think of uh, not really, we will talk about in details, but for time being, MapReduce is more like being able to devise your logic such that you can solve your most of the problem. The most closest definition of MapReduce can be your group by clause, where their group by has two parts. One is group by this column, and other is aggregation, create average on this column, right? If you guys are familiar with SQL, group by SQL group by has got two parts. One is group by this particular column, which is column selection, and other is aggregation of other values. Similarly, MapReduce has got two parts, map and reduce. Map gives the ID to the system that group my data by this column, and reduce tells to the system that this is how you aggregate my data, right? And this paradigm is able to solve most of your data problems, as complicated as finding the path from one place to another, or as complicated as uh, doing a matrix multiplication. I just posted a code on my blog where I did a matrix multiplication on a very very huge data using MapReduce paradigm. MapReduce is more like a paradigm, as well as MapReduce is more like MapReduce has got two part. One is being able to distribute the logic, other is being able to use a paradigm in which people write map and reduce code which gets executed onto multiple nodes, right? Now the other parts of Hadoop ecosystem are Hive. Hive is basically an SQL interface which provides you a simple SQL interface to access HBase. HBase is NoSQL database. Using you can access that using your simple plain SQL, and using Hive, you can continue to use SQL to do lots of processing on top of Hadoop distributed file system. If you do not want to write your code, your logic into code, because writing every time code in any programming language is very, very time consuming as opposed to writing SQL. And therefore, anything you write in Hive gets converted internally into MapReduce paradigm and gets executed onto the whole cluster. So that is the magic Hive plays. So you continue to write happily your SQL code without having to bother about writing code in Java or any other programming language for MapReduce. Now similar is Pig Latin. Pig Latin is basically a new form of language which is very, very closely similar to SQL. And since SQL was designed for other use cases, it was getting difficult to do the optimization in SQL, and therefore they came up with a very decent language called Pig Latin. This was done by Yahoo guys, and and Pig Latin, what I found with Pig Latin is it is like the easiest query language to learn. And I found that even people with the SQL background, when I give them exercises, they solve those exercises using Pig Latin rather than Hive. And that is the magic which Pig Latin has brought in. I have seen lots of people using Pig Latin in my session, and they have got very, very comfortable with it. Okay, but Pig Latin is similar to SQL, but you can do things in stepwise manner instead of having to write the whole query in a single shot. So here in Pig Latin you write a statement, do this data with this one, form a new table, and all that sort of thing. We'll go into details in one of the sessions. There are two sessions which I take for Pig Latin. One is simple and advanced. And Hive has got one more property. So Pig Latin is used when you basically Pig Latin is exactly used for the use case of Hive. Okay, but for the cases when you need a better better performance. Okay, better performance, right? So Hive is more or less for people who have been using SQL day in day out, or existing systems who depend on SQL, while Pig Latin is for those who are trying to build fresh new systems. And Hive has got one great property. Hive has got one great property in the sense that Hive lets you combine the data from your data warehouse or other places with the HBase or data lying in CSV file, tab separated file. So you can combine your tab separated data, you can represent the tab separate data as a table in Hive, and then join that table with a table in your enterprise data warehousing. That is the beauty of Hive. While Pig Latin is just for data churning, an alternative to most of the query interfaces. And both Pig Pig Latin and Hive are into competing stages. Just that Pig Latin has got a new language, a new programming language, so learning curve is bad, but performance is better than Hive. Now the third component is Mahat. Mahat is basically the magician of the whole game, right? You the way when you churn the data, you present the data into some chart, some other form, and some graphs or other form. At Mahat, you build various kinds of greater insights, such as group people together who have similar behavior. It's as generic as this, or build my recommendation based on this data. So Mahat is basically a collection of various libraries, hundreds of functions, just like you have summation, average, and statistical standard deviation in standard mathematical libraries. Mahat gives you similar kind of functions to do machine learning based algorithms and machine learning based, the insights into the data. Yes. So Mahout is used for classification and classification and clustering. The algorithms are really, really great and very, very sophisticated. You don't have to learn any of those algorithms. You just need to understand the philosophy, what kind of data those algorithms require, and what kind of data will they give you back. As simple as that. All right. I've used Mahat exhaustively for a couple of projects, and I'm really, really fan of Mahat in general. So, I'm not a data scientist per se, though I have been, when data scientist means I should have a statistics knowledge, I mean, classes, and I should have a knowledge about various kinds of signal processing. But Mahat has made me learn all of it without worrying about going back to the college, right? So basically this is a very, very beautiful thing that has happened, that these all things are in open source and available to all of us. Now there is something called Uzi is a workflow system, because when you will be writing your game. Okay, before I move to Uzi, let me talk about two things. The data import part, you have got two tools. One is Flume, other is Scoop. Flume is for moving unstructured data to HDFS from, say, you have 10,000 servers, or say you have got, let's just stick with 20 machines. If you have got 20 machines running your web server and generating lot of logs or all kind of thing, Flume will flow that data to HDFS and will help you, taking the whole log seamlessly to your HDFS, so that you can do various kinds of processing on the top of block. Now, the second one is Scoop. Scoop takes the structured data from the databases to to HBase or Hadoop file system. So Scoop actually helps you a lot in that. So one class is dedicated to both Flume and Scoop in one of the things, where we give a hands-on experience on both of these things. Now, this is pretty much about the whole ecosystem of Hadoop. Uzi is basically combines the whole workflow into one, because when you build a project, or when you build a project which does these all things daily or at a particular schedule, you will require some sort of a scheduler, and which will say, first import my data from using Scoop from this to this, then execute these commands on HDFS, then run my MapReduce logic on top of that data, whatever comes out, run my Hive queries and give me the result. So that sort of stitching is done by Uzi. You can think of Uzi like any make Ant or Maven kind of program, or any build script. You can think of Uzi like a build script executor or workflow executor, right? And at the end of it, the user can interact to the system via Uzi or via command line, via Java or Python program, using the drivers to the whole ecosystem. So this is pretty much about the whole ecosystem of Hadoop. So this whole umbrella of product, including Apache Spark, that is missing from this diagram. I'll add it in the next session. Okay, Apache Spark is also something which we teach, and Apache Spark and Zookeeper also we teach something, both of those things. Yes, I'm going to share this PPT to all of you. It's just that you'll have to fill a form. I'll send you the link to the form, and then you fill that form. I'll send you this PPT. Plus, I'll be sending you the certificate for this course. Okay, so you just have to fill that form. I'll send it to you. Right now, these are the core components of Hadoop. So let me just go into the details of HDFS cluster. So HDFS cluster is actually very, very simple. So let me just describe HDFS cluster very quickly. It has got one admin node and others are data nodes. Data nodes store the data only, while admin node stores the metadata related to your data. So The whole workflow goes like this. It's very, very simple if you listen to this carefully. So so there is this master node or a name node, admin node, master node, whatever you want to call it. It doesn't do anything. It just does a bookkeeping, right? While the data node are the real guys who does the heavy lifting of storing and retrieving your data, right? And there is only one single admin node while there are lot of data nodes, right, on multiple machines, right? Now, whenever you have to store, say, 1 GB of file, you will go to name node. Hey, I want to store this file. Name node will, uh, you know, give you an answer back that first 64 MB of your data. So it will give you that, divide your file into a chunk of 64 MB, store your first chunk 1 from 0 byte to 64 MB into node 1. The second chunk goes to node 2, third chunk goes to node 3, and so on. Now this is the list name node has given back to you, basically a plan. And then you take this plan and go to each node and store the data, right? When I say you means the client library you will be using from the command line, right? So that client library goes to the name node. Hey, I want to store this file. Name node says that, see, I don't really do everybody's job. All you have to do it yourself. You go to each data node, and store it here and here. And once you are done, inform me. By delegating this load back to the client, it has avoided itself becoming the bottleneck. Okay. Now imagine that, had name node been taking the request from all the people and talking to data nodes and bringing writing all the data to data nodes, taking the request from the user, name node will become the bottleneck. And therefore name node keeps itself as free as it can by playing a role of proper bookkeeper. Okay. You went to name node said said that, divide your data into these pieces. Now go to each machine and store there, and report back to me once you are done. In case you don't report to me, then I'll assume that you have not stored the data, right? And the other role so now this is the way, and exactly the same way, when you try to read the data from the name node, exactly the same way happens to the so you went to name node and said, hey, I'm looking for the this movie, and name node tells you that these are the node containing these pieces. You can get it from there, right? So this is how name node is able to distribute the whole load to thousands of hundreds of thousands of nodes. And that is the beauty of name node. All right. Now, this is what how the name node functions. The other thing which name node does is the replication. Each portion of the file, as said, that it divides the whole files into chunks and and puts it on each data node, and makes a note of it. Then each chunk of the file is also backed up. It has multiple replicas and is stored on multiple nodes. That is pretty much about HDFS architecture, right? Now, each portion of the file is being copied at multiple places. In case one data node is down, that portion is available elsewhere, right? And also it keeps on maintaining that replication factor. Total number of copies of each portion should be constant. In case one node goes down, it copies that files which we just lost onto another node from one of the replication, and thus retaining the same guaranteed replication. All right. So yeah, client is the client library. In this, the client is the client library, either the command line or your driver. All right. It's not you. It's not like when I interact with HDFS, it gives me a list, and then it will be too much of mess for a user to do that, or any application user. So user generally deals with the files, or user has this flexibility of asking for one particular piece. Now imagine this: a new movie came in and it stored those pieces all across data nodes. And so when the user is watching the first 5 minutes, it will be accessing from the first data node and then move on to the second one and third. So all of the data nodes are equally loaded, no matter how many people come in. Also, since each piece is copied to multiple nodes, so it multiple nodes can serve the same piece, right? That is the HDFS architecture. And similar is the architecture of MapReduce. MapReduce also has got a master, and then there are task trackers. Job tracker, task tracker. Job tracker takes the job, and task tracker takes care of individual task. So whenever you have to get anything done from the MapReduce engine, or get anything done from Hadoop, Hadoop MapReduce, you ask job tracker, hey, can you do this for me? And then it will find out all the task trackers which are closer to the data, which are nearer to the data which you are trying to process, and process those portions of the file and give back the results. And that is the magic of task tracker. So task tracker will ask name node, hey, can you tell me where is this file located? And name node tells you back that, hey, these are the portions of the file located at various locations, and now you can go back to these task trackers, these data nodes, and access this file. And job tracker will find out which are the task trackers running nearer to those data nodes containing that particular file which you are trying to process, and will send your process to those nodes, right? So that is the architecture. This is the general architecture of handling the data by job tracker. All right. So that's pretty much about the MapReduce and HDFS. Okay. Now I mean, the way we provide hands-on is using these console we provide, so that you can go through the whole architecture. And if you are going for the full course later on, you can go through the learning management system, where all of the recordings, the current session is also getting recorded. All of these recordings are uploaded. In case you missed anything, you can review it. Okay. Also, assignments and everything is in our learning management system, which is under my courses. All right. So, and that's pretty much it. If you want to read further, there is a Wikipedia page which is great, and the manual on Apache is really great. In case you want to go for the full course, you can. The next session is starting from 11th October, and these sessions are on Saturday, Sunday from 7 a.m. to 10 a.m. Okay. So these all of our sessions are on weekend, and you can attend on weekend, so that you know, it doesn't interfere with your office. So every Saturday, Sunday, it's for 3 hours. You can attend these sessions, and this is pretty much about us. Okay, and we provide a cluster for hands-on experimentation. And now you can ask your questions. Now I have answered Umesh's question, and okay. Now you can ask your questions and let me uh, answer your questions. For next half an hour, we can take up the answers, questions. So in the second half, I went through the whole ecosystem of Hadoop, like HDFS, MapReduce, and all. Yeah. So Vivekanand has got a nice question. He says, "What if admin node goes down? Is it possible to read from data node?" if admin node goes down, there is something called secondary node, name node, and there are other other backup mechanisms of the hot. There are hot backups of the name node, but uh, so in case name node goes down, then you can do that. Okay, so is it possible to read from data node? So let's say that you were reading from name node. Name node gave you that this is the list of chunks available, and now you can go. In the between, it went down. So still you can keep on continue to read from the data node without bothering name node. Okay, while the name node comes back to life from the backup. Now, so that was Vivekanand's question. Now, what code exactly we write in MapReduce program? So, as I was describing, so MapReduce is like the map and reduce are run parallelly on multiple machines, and each small portion of the data. Map is run on each small portion of the data, right? So, and the objective of any map is to give out key and values. Okay, and so basically map and reduce is more like two functions you are giving to Hadoop. This is my map function and this is my reduce function. This map function tells Hadoop that you can this is my key for the data on which you can group my data by, and this is my aggregation function which is reduce. You can you once you have grouped the data by my key, you can run my function this function on for preparing the aggregation. Your group might be doing your aggregation function, which is reduce function, might be average, might be sum of under root of sum of square roots of all the functions, and it could be anything. Reduce can be anything. It could be as simple as aggregate all the values by putting commas between them. Okay, so that is reduce. Maps role is defining an id for the data on which MapReduce framework will group the data by that column, and this whole process goes by network. So you can see that. So each portion is split 0, split 1, split 2. On each of these splits, which are these portions are existing in multiple computers on multiple machines, and map is being run on each separately. This map is basically your code, your simple code. Map can be as simple as that just take the first value from the column and then put it back on as the key, and that's all. So we can go back. I mean, MapReduce itself takes some time to get used to. Therefore, I take total number of 3 classes to to describe MapReduce paradigm. Okay. Does your course does your course also involve basic programming needed for Hadoop? I try my best to explain the whole Hadoop paradigm in simple examples, and one there is one session, third session. For first 1.5 hours, I go through the Java code in which I explain how to do the programming on Hadoop. Okay, so but I do not go with teaching the Java basics or any other programming basics. Okay, but what I have observed it, even without learning Java or any other programming language, you should be able to handle it. Okay, it wouldn't be that difficult in case you have done any programming ever, even during your college time. Okay, if my file has 10 blocks, so will name node give block by block info to client to write, or block location at once? So it name node will just give out the list of all the blocks to the client, and then it's up to client which copy to use. Okay, which blocks to use. So it will give all the block locations as you can see in this diagram. This is the metadata which exists on the this is the okay This is the metadata which exists on name node, where there's a file name, the number of replicas which has it has guaranteed, the block IDs, and where are these blocks existing. Okay, so all of these information is given back to the client immediately the moment they ask, or client can also ask for a special individual block. In case you are building a streaming service like YouTube, you can say to HDFS, give me only the only this particular block. Okay, and then you can go to that particular, or you can maintain a backend service which maintain this metadata, take reads this metadata from name node and then move ahead. All right. Yeah. So okay, did I miss out any questions? Okay. But Suchita, I am planning to actually do maybe a basic programming, the complementary course on basic programming, like very very simple Hadoop, Java basics or C Sharp basics. But that is still in the plan. Okay. How many data node can we have? Is there any limitation of data node? No. I mean there is no limitation per se right now. Okay, it all depends on how great your name node is. Name node stores most of the almost all of the data into the memory, keeping the backup on the disk. Okay, so the moment right now the data nodes limit is too high, and it is directly proportional to how big is the name node's memory, right? Also, name node does a further optimization, like in case the name node's memory grows smaller or is not sufficient, it starts increasing the size of the chunk from 64 MB, which is default, and hence practically you get an infinite number of data nodes, because as size increases, the name node will be able to store more metadata information. What is the ID used for Hadoop? There is no ID for Hadoop. Okay, ID generally used for your programming convenience. There is no ID per se. Okay, because Hadoop is a is a suite of components, right? And it might have pig Latin. For that, there might be an editor highlighting, and it might have MapReduce, which might have Java highlighting. Okay, so these are different ones. So the most suitable is Eclipse for most of your job. So Visual Studio is yet to come up with something, although Microsoft has come up with great Azure cluster called HD Insight, where you can write in C Sharp as well. All right, but uh, the piglet in highlighting is not there. What is the way to validate and verify the data at each and every phase of data transaction in Hadoop? So yeah, that's interesting question. So most of the time when you do the validation, you will have to write your own checks and passes. Okay, and the best way is probably using either pig Latin. Most likely you will, in case you are validating and verifying the data, the pig Latin will solve your problems better. Okay, and in only in few circumstances you might have to write your user defined function in pig Latin, or in extreme cases you will have to do MapReduce for validating and verifying the data. But in case you are building a data science kind of a project where you need to build a recommendation, the smartest thing to do is slice your data into two parts, generate the recommendation or insights on the first half, and then verify those that insights, and validate or verify those insights on the second half. Okay, it is like asking a future teller about your past and validating that with present, just to verify that future teller is telling the truth. Okay, so that's a technique which we always use to verify and validate lots of data or the insights. how do we write program? So there are two ways to write map reduce program, but one is in Java, other is in using streaming. In case of Java, you write your classes, write the map function, write the Java reduce function, like using, if you see a hello world, you will be able to figure that out very quickly. Once you are done with writing this, you compile it and prepare a jar, and then run it on the cluster. It is as simple as that. And there is another one called Hadoop streaming. The job is really beautiful. It lets you use any command as map function and any command as reduce function. All you have to do is run Hadoop jar and map this streaming, and specify your command which will be used as map function and which will be used as a reduce function. And as an example, you should look up for Hadoop streaming. I mean, this we cover in the second session. It'll be far more clear if it will take at least half an hour for me to give you an example. Okay. So Mirunalini's question is that, is SAP HANA alternative to big data, or it can be used along with it? Okay, so since my voice is breaking, I'll try to be slow, and I'll be repeating myself at least twice. Okay. So SAP HANA is basically a in-memory database. In-memory database. So SAP HANA basically stores all of the data into memory. And SAP HANA also comes with the hardware. Okay. Now this in-memory data is supported with a disk. Okay, in case the memory goes off, you can store it on a disk. But I do not find that SAP HANA should be really big data solution. But SAP HANA has a great advantage over most of the other solution, that its processing is more than 10,000 times faster, because the read speed from RAM is really fast. Okay, but when your data cannot fit into the memory, then SAP HANA is equally useless, right? So SAP HANA is a great tool when you have to do really difficult processing or really fast paced processing in the memory itself. Okay, say for example, you are doing a computation on stock prices. Lot of prices are coming in continuously, but uh, basically we are updating the prices continuously, we are not increasing the data, and therefore we do not require too much of data memory. Okay, and such kind of things are far well suited for HANA kind of solution where everything is in a memory, and therefore SAP HANA has got its own use case, but is not really alternative to the whole Hadoop cluster. Okay, Redis is an alternative to SAP HANA. It's a small use case which they cater to. In case of a big data problem, as we talked about, there are multiple kind of issues that could come in. The data is so huge to even store. Data could be so huge to get processed, or data could be small, but the pace at which the input is coming is too high, and we need to process it really fast. So so when we talk about the velocity, HANA is really good, but when we talk about the volume, the HANA is not really great. Okay, so those are the pros and cons, and one of the sessions in the last one, I go through all of these solutions and help the candidates out when to use what. Okay, Mrinalini, was I audible, or did you get anything out of my? Yes, it can be used along. It can be used along with Hive. So did I miss any question? Okay. So somebody was asking before the presentation, before the second half, was her question answered when I was telling that you can look into the second half? Okay. Yeah. Great. So that's pretty much from my side. If you have any question, feel free to drop me an email. And before you log out, just go through our website like knowbigdata.com, and also we have got Facebook page where you can rate this review, rate this. Okay, and fill in this form. Fill in this form where I will all the people, because I don't have email ID of everybody, all those people who fill in this form, I'll send out the video recording of the session. Okay. Okay, so fill the form, and then yeah, I'll send you the details. All right. So
Yeah.
Mrinalini's question
Hi.
is,
Yeah, tell me. Yeah.
uh, should I mute you?
Hello.
Yes,
Hello.
yes, yes, yes.
Yeah, this is Jahin from Chennai.
Yes, Jain, tell me.
I have one clarification with respect to cloud computing.
Mm-hmm.
So how we relate this cloud computing with big data, and what is the relation between these three, Hadoop, cloud computing, and big data? Like, uh, where it is used and what is the purpose of it, and what is the scope?
Okay, okay, okay. So yeah. So basically, whenever we require more than one computers, okay, we call it that we are handling big data, right? When it is inevitable to use multiple computers to process or store your data, then we call it that we are handling big data. And now the moment we start using multiple computers, you will inevitably have to set up this cluster. And the moment you move these nodes to somewhere else remote, we start calling this cluster as cloud computing. Okay, so these terminologies are very, very well connected and also used interchangeably. Okay, so you can actually unmute yourself, because I'm not able to figure out which one is your ID, because L&T Infotech, there are three IDs of L&T Infotech. Was I able to answer your question?
Uh, yeah, if I'm not wrong, I mean, like, clusters, whatever we divided, we split it and we save it in, so many servers. We call it as a cloud, correct?
Right, right. So cluster
Okay,
cloud is
fine.
interchangeably used, and the kind of processing we do on clusters, and when our when our data processing or storage requires cluster or cloud computing inevitably, then we say that we are handling the big data.
All right. So, is there any specific no norms or regulations, like, for cloud computing, like for cloud, for maintaining a cloud?
Mhm. Okay, so the only norm which we consider as is the availability part. Okay, that's where almost everybody competes and everybody promises, and those are 99.99. How many nines can you give? Okay,
Okay.
with respect to availability, and that's how people are characterized, that this data center gives us this much of nines, and this data gives us this much of nines after 99 point. Right.
Okay, fine.
Okay,
Thank you.
yeah, thank you. So there's one question which says, where do we write Hive, Pig, Latin, and Mahat? So basically, Hive, there is a command line for Hive which says, when you type Hive, it gives you that. Pig, similarly, there is a Pig command line. And for Mahat, there is a Mahat command line. Similarly, for Hive and Pig, there is an interface as I showed you very, very briefly about this screen. This hue is the web console where you can, as you can see that, uh, let it open, it is opening. So this is a web interface from where you can execute your Hive queries. This is your pig query. You can execute your pig query like here. People have written their pig script. And
Sandeep,
yes,
Sandeep, sorry to
yes.
interrupt. Are you on slide number 11?
uh, no, I'm not slide number 11. I am on slide number 49. And here I am trying to show a browser, my browser. Okay.
Actually, we are not able to see the slide you are using.
Yeah, we slide number 11 actually, all these times.
This one, can you see it now?
I think, can you check whether you are connected to the GoToMeeting, because we have seen a notification like you are no longer connected. That might be the reason.
Now can you see this now? Okay, never mind, never mind.
No.
Never mind. It's almost over. So I'll just there is nothing much to show right now. Okay. So do not worry about that part. I'll send you the PPT. Okay. I'm trying.
ஷேர் பண்றீங்க சரி நம்ம இமெயில் ஐடி இருக்காமா
Don't have any information.
Okay, so just fill in that form which I've sent to all of you. I'll send you the PPT and that will be all right. Okay. And yeah, so I was just answering someone's question. How do we write Hive, Pig, Latin, and Mahat? They all have got command line as well as they have got a web interface via a program called Hue, Hue. I'm also typing it. Okay. And I was actually trying to demonstrate Hue, but uh, I mean, you can go through the Hue yourself. So, right. And
Yeah.
how do you load
Hello.
yeah, tell me.
Yeah, we don't know the form because we are not able to see that. Can you
No,
share the form?
yeah, I have actually put it on the chat. Okay. Okay. I put
In the
it on the
chat.
chat. Okay. I put in the chat and someone also send an email with the link. Okay. I will
So
ask.
it's a link, web link.
Yeah.
It's a web link.
Yeah. It's a URL.
So can you show that, because I'm not able to find that.
Okay.
Can
So
you send it
this
again? Can you
yeah,
send it again?
yeah. Let me copy it. I mean, okay. Some coordinator will send you. Do not worry. Okay. I'll send it with training coordinator and they will send it to you. All right.
Sure. Thank you.
Okay. Great. So there are a few more questions. And how do we load the data into HBase? Any command etc. As I was explaining, there is a tool called Scoop. There is a tool called Scoop in this ecosystem. All right. And this is the one. In case you are not able to see, do not worry. The term is as Scoop. Okay. So that one is the one you use for importing the data into HBase. If cloud computing and big data are related, then Azure and Microsoft Cloud also use. Yes. Azure actually uses big data, Hadoop actually. Okay. And Microsoft Cloud is the infrastructure on which Azure runs. So how do we link pig and MapReduce? Okay. So whatever query we write for pig, that query language called pig Latin internally converts the whole logic into map and reduce functions and calls MapReduce and does the job. And now when we are talking about linking, the linking is happens this way. Your MapReduce code will write the data into file system, and that file can be further processed using pig. Okay, so you can queue them together, or you might use pig itself to do MapReduce job, whatever is comfortable for you. Okay, was I able to answer your question? Okay, was I able to answer your question about how do we link pig and MapReduce? So course is around right now it's for 15,000 if you sign up now, and from next week onwards it will be 16,000 for the whole course, including cloud labs, everything, and all the taxes. And since we are ourselves giving, ourselves giving the training, that's why we have kept it the low as compared to all other people.
Sandeep, to whom we have to contact for that training?
You can call me up, or you can drop me an email at sandeep@knowbigdata, or you can write an email.
Can you
Yeah. So this is my email
can you
ID.
give me your email address or share it in that chat window
Yeah. Okay. Or you can actually, you can
with your
come.
mobile number?
Yeah, I'll just write it down. Okay. And we will, yeah. So my mobile number is 9538998962. All right. So that's pretty much about me. Okay.
Sandeep, we are not able to see anything in the chat window.
Don't worry then. I'll send this email with the via placement coordinator to all the people. Okay. All these details will be there.
Okay.
All right. Nothing to worry
Yeah.
on that.
Is this PPT available online, Sandeep?
Yeah, it is available online. Okay, if you go to our blog www.knowbigdata.com, okay, and under blog you can see the big data and Hadoop session presentation, and it has got one older video, not this video, with it. Okay, you can watch that one. All right. So if you go to our website www.knowbigdata.com, under blog you will see big data and Hadoop session 1 presentation. Okay, you can see it there. All right. Any other questions? All of these details I'll be sending it to you. Swantika most likely will be sending it to you. And some of the people have already filled the form. Great, great. So looking forward to hear from all of you. If you have any doubt regarding any of the components, and even if you are not attending any of my sessions, you feel free to drop me an email in case you have a certain project you want to do, or you have any interest in the big data. Feel free to communicate to me and connect with us. All right. So thank you very much, and it is going to be good. Mrinalini's question is that what are the different job roles in Big Data Hadoop? There are different kind of job roles, starting with Hadoop administrator, Hadoop developer, Hadoop analyst, and big data analyst, you can say, and then there is a data scientist. Okay. These are all all our classes. We have actually stopped our classroom based training because classroom based training required, basically all the people who attended our classroom trainings were not performing great. Their assignments were not good, so we stopped our classrooms because our online sessions performance was pretty good, so we stopped. Are there any professional industry recognized certificates? Actually, some of the people have started respecting the certificates of various parties, such as Cloudera Hadoop, or Hot&Works, MapR Technologies. All these 4 or 5 companies, they also give certificate, and we also provide certificate. But most of these certificates are not does not matter too much. As a novice, to which role one is suitable in Hadoop? So mostly as a beginner, right, you should generally go with the Hadoop developer kind of a role. Hadoop developer is similar to the Hadoop developer or Hadoop analyst or Hadoop administrator. Either of these three roles can be entry point for anybody. Hadoop architect is the next level after Hadoop developer. So that was Mrinali's question. So okay, as a novice, which one role is suitable in Hadoop? Okay, but these roles mostly are very company dependent. I was actually reviewing the roles by Morgan Stanley and lots of other firms which have openings. They have a Everybody is having their own names for the titles right now. You'll have to look into the details, like what is it they are expecting. Hello?
Sandeep, can you give your mobile number?
Yeah, my mobile number is 9538
Yeah.
9989
Okay.
62.
95389 98962.
No, 9538 998962.
Okay.
All
Thank you.
right, great. So, okay, that's pretty much. If you have any question, then drop me an email. Does Hadoop architect role require database? Yes, of course. Yes. So most of the career people from Java architect, the most organic way to move ahead for a Java architect to become a big data architect. Not only the Hadoop architect, but big data architect properly. That is the best career to have after Java. Y- Okay. So I'm a data architect and have no idea on Java. So a lot of data architect you will find working with Python or shell programming. So Java is not like mandatory criteria if you are going into a big data architect kind of a position. Or
Sandeep, what will be the next session?
huh?
What about the next session?
Do we have more sessions?
Next session is not free. Okay. So next session is
Okay.
going to be about how to set up the cluster, how to do the, I will go through the whole environment and run the basics of
Okay.
these MapReduce. Okay.
Okay.
Yeah.
So that will be, fee, the course, what will be the course fee?
Course fee is around 15,000 right now for this week
How
only.
many, how many session totally?
Totally 10 sessions, but the thing is generally from 10 session we end up having 11 sessions because a lot of people ask a lot of questions. Okay, so
Uh-huh.
generally it is 11 sessions, 10 more sessions basically. This is the first session.
Okay, the duration and the timing?
Duration is 3 hours. 3 hours, each session is three
Okay.
hours long. All right, and there are
Mm-hmm.
10 more such sessions which is 30 hours plus it will be from 7 a.m. to 10 a.m. every Saturday,
Morning.
Sunday. Every Saturday, Sunday.
Every Saturday and Sunday. Okay.
Right.
Yeah.
Mm,
Thank you.
okay. So is it possible to work on Hadoop? Yes. Basically, I mean, that is the reason I have set up Cloud Labs for all my students. And that is so that they can start working on Hadoop. Okay. So that is pretty much. And thank you very much. And feel free to connect with me in case you have any doubt, any questions. And okay. Thank you, Vivekanand. Thank you, Umesh. Thank you, Ritesh. Thank you, PC user.
Thank you.
Bye bye.
Yes. Thank you.
Yeah.
Thank you, Sandeep.
Okay. Thank you, Nilesh. Thank you, Mrinalini. Thank you, Aarti. Thank you, Jatin. Thank you, Bangalore team. Okay.